Listening practice test, tornadoes. Picture the most violent of all tornadoes, a violent whirling column of air with speeds of 100 to 300 miles per hour, a funnel which extends downward from the cloud, almost always seen as rapidly rotating, a funnel-shaped cloud which usually destroys everything in its path. More than anyone else in the history of meteorology, Tetsuya Theodore Ted Fujita increased our knowledge of severe storms, especially tornadoes. Here's a brief list of what Tom Grazoulis, director of the Tornado Project, considers to be some of his most notable achievements. Professor Fujita was brought to the United States in the early 1950s by Horace Byers of the University of Chicago. He proceeded to change the course and the speed of severe storm research like no one else in this century. Shortly after his arrival, he began analyzing single thunderstorms the way larger systems had been studied for decades. He saw them as individual weather systems, which he called mesoscale systems. Fujita introduced the concept of tornado families, which are made up of individual tornadoes, each with a unique path, but spawned by the same thunderstorm. Prior to this, long damage paths were usually considered to be made by a single tornado. Through analysis of the photographs of the Fargo, North Dakota storm, he introduced the concept of thunderstorm architecture and terms like wall cloud and tail cloud. He saw in these storms things that we take for granted today, but it took a genius to see them for the first time. In the 1960s, his analysis of the Palm Sunday outbreak of 1965 again changed the course of how we view a tornado outbreak. For the first time, he mapped the entire outbreak in terms of tornado families. From the thousands of aerial photographs of Palm Sunday damage, he concluded that there was indeed something special about certain tornadoes, that they must contain more than one vortex. While multiple vortex tornadoes are well known today, he was the first to identify their existence based on damage patterns. In the 1970s, he again revolutionized tornado climatology by giving us a system that linked damage and wind speed. Previous to this, all tornadoes were counted as equals. Today, the term F5 is used casually by the general public, and in movies, without Ted, one can only guess whether there would be any system at all. The super outbreak of 1974 was the pinnacle of his analysis of a tornado outbreak. For many of the 148 tornadoes, he was able to map the entire path in Fujita scale intensity contours. Confusing damage patterns from this outbreak would later allow him to identify a new kind of windstorm. He would also mentor a group of students who today are among the leaders in many areas of meteorology. His ability to simplify concepts of severe storms was a great aid in public education and allowed others to better educate the public. After 25 years, we still use his ideas and terminology. Later, in the 1970s, he turned his focus to weather-related aircraft disasters. From this and his studies of confusing damage patterns in the super outbreak, he identified two other phenomena that we take for granted: the downburst and the microburst. Prior to this, meteorologists had been confused by a bewildering array of gusty winds in and around thunderstorms. By the 1980s, the downburst and microburst were being studied as a unique phenomena generated by things such as an intrusion of dry air. At long last, we had a way to distinguish tornado damage from damage of non-tornadic winds. Then, as you know, he passed away in 1998, leaving a vast amount of useful research for meteorologists.